So in case of the lithium helium ion and the charge is +2, the lithium is having 3 proton, that means 3 positive, and of course it is having the 3 electron because proton and the electron would be the same for the neutral element or the molecule. And in case of the helium, there are 2 protons, +2 charge, and 2 electron, -2 charge. And that means there is -5 electrons plus +2 is the charge on this lithium helium ion, and the total number of electrons will be 3, because this is going to cancel out the effect of the true electron, and then the net charge will be -3. So actually, what we are going to do, we are going to calculate how many total number of protons are there and how many number of the electrons are there. So there are 5 total protons, and this is the nucleus of the lithium is having 3 positive charge, and the helium is having the 2 positive charge. So this charge belongs to the nucleus, and the rest we have 3 electrons total over here. So this is the net output to consider the number of protons and the electrons to calculate the potential energy. So let's start. I am going to do again this exercise and solving this one, and then I will give you another very simple example. And so listen carefully and do right now after this lecture. So 3 positive, I am just indicating lithium. You can put the lithium over here, or better in a general form, we are just labeling lithium with A and the helium with B, just to keep the simplicity to calculate the potential energy. And other one is the helium ions, and helium ion are having 2 positive charge because the number of protons are the 2, and there are 3 electrons. So I am just labeling the electrons with their number. So this electron, I am going to label this 1, and this electron with 2, and this electron with electron 3, just to differentiate, because if I am not going to label, then it is difficult to understand which electron is there, which is having the repulsion between them, and it will be difficult to understand whether this one is repulsing electron 2 and one is going to repel electron 3. So that's why I have labeled all 3 electron with 1, 2, 3, and the nucleus with A and B. Similarly, if there are 3 atoms, you can label as A, B, and C. And if there are more electrons, and you can also label, let's say 4, 1, 2, 3, 4. And there is, I think there is, should not be any confusion in writing or calculating the nucleus and the electrons. So it is better to understand over here. I'm not going to separate the or labeling the number of the protons, because here it is only, I'm going to mention the nucleus, and this is also the nucleus of the helium. So the atoms with nucleus are mentioned over here, and electrons are being labeled 1, 2, 3. So the first is, let's start with this one. This is the repulsion between, of course, because this is positive charge, positive, these are going to repel to each other, and this is the radius between these two ions, and sorry, between these two nucleus, and it is labeled as A and B. R will remain the radius and the nucleus, because this is A and B. That's why I have written over here, this is the R, A and B. Second repulsion is here. This is the repulsion between electron 1 and electron 2, and R is the same as written over here, and this R is indicating the distance between the electron 1 and 2. That's why it is written R1 and 2. And similarly, you can put over here the distance between these 2 electrons, and these two electrons are labeled as 2 and 3. That's why it is written at R2 and 3. And what is left? This is the third one, sorry, the fourth one, repulsion between the electron 1 and electron 3. So this is all about the repulsion we have discussed over here. If you have a look keenly over this example, then you can find there is no further repulsion are available, because all these similar charges which are going to repel to each other, I have mentioned over here. Now, this is all about the repulsive forces. Now, I am moving to the attractive forces. Attractive forces mean this proton or this nucleus is going to interact with these three electrons, and this nucleus is going to attract between these three electrons. So let's start with the one. This is the attraction between A3 positive and this electron, and the distance between these two, it is R, and this is A and this is 1. That's why it is written RA1. This is the attraction between uh, the A and electron 2, and that's why it is written over here. This is the RA2. This is the distance between these two proton or the nucleus and the electron, and this one is the third attractive forces between the lithium nucleus with the third electrons, and the distance between these two is the Ra3. R belongs to this nucleus and 3 belongs to this third electron. And similarly you can do with the B positive, and this is the attraction between B and electron 1, and that's why it is written RB1. And the second is the RB2, because it is the attraction between this B2 positive and the electron, and third one is the attraction between the this B and the third electrons. So this is all about the total maximum attraction forces are available. So total repulsive forces are 4, and total attractive forces are 6. 3 due to this nucleus, due to the nucleus, helium nucleus, and 3 due to the sorry, 3 due to the lithium, and 3 due to the helium nucleus. So if you want to write the net potential energy, this is all about, if you correctly label or understand what is happening over here, then you can only write this net potential energy, and this is just we have explained earlier. So let's start with the first one, repulsion. So this repulsion is between A and B. Sorry. So A is 3 positive and B is the 2 positive. When 3 positive is multiplied by the 2 positive, it will become 6, 3 to the 6, and positive coming from plus multiplied by plus. This is that's why the sign will be the plus. E square will remain the same in all of the potential energy. This is the electronic charge, and this is going to vary because this is the distance between A and B. That's why it is written over here A and B. And similarly, you can do with the rest of the attractive and the repulsive forces. So this was our second repulsion forces, and this is the minus multiplied by minus. So net charge will be the positive, and e square, because 1 multiplied by 1, that means it will remain 1 e square, and this is the distance between these two electrons, and this is R12, and this is written over here R12. And again with the second one, second and third, this is the minus multiplied by minus, the sign will be the plus, and E multiplied by E, the sign E square, and this is the distance between these two, this is the R R12. And similarly you can do with the electron 1 and electron 3. and this will remain the same. The sign will be the positive, and the distance will only is going to change, and this distance is r13. R is indicating is the electron 1, and 3 is indicating electron 3. So this is that. Now you can understand why I have labeled the electron 1, 2, and 3, and you can easily differentiate over here. If it is 1 and 3, that means electron 1 and 3 I am going to talk, and if it is 2 and 3, then the electron 2 and 3 is the going to repel to each other. So if you are not labeling correctly, you will be unable to differentiate between, let's suppose, these repulsive forces and this repulsive forces. And similarly, you can do with the attractive forces. First, it is the lithium, and this electron nucleus is going to interact with the first electron, and 3 multiplied by 1, the net effect is the 3, plus multiplied by minus, the charge is the minus, and the distance between these two is ra1. R is a and 1 is the 1 electron. This is ra1. Similarly, you can do with the second electron. Again, this is the plus, this is the minus, minus multiplied by plus, the sign will be the minus, and 3 multiplied by 1, the net unit will be the 3, and this is the e square coming from the formula. This will remain the constant, and the distance between these two is ra2, and that's why it is written over here ra2. And similarly with the third one electron and the a3 positive, and now 3 multiplied by 1, again this is 3, plus multiplied by minus, the charge will be the minus, and the distance between these two is ra2, sorry r this is the ra3, sorry, this we are going to talk with the third electron. And similarly you can do with the b positive, and b positive is the plus multiplied by minus, the sign will be the minus, and the 2 multiplied by 1, there is the net effect will be the 2, and the distance between these two b2 positive and the 1 electron is rb1. So that's why it is written over here rb1. And similarly you can do with the second electron, and this will remain the same, just that the distance between the proton and electron is going to be different, because due to having a different labeling of the electrons. So with the second electron this will become rb2, and with the third electron this will become rb3. So this is all about the exercise I have given to you, and if you take more interest, you can do yourself by using any of the molecules which you consider it would be interesting for you to calculate the net potential energy. So with this one, I'm just